All right, I want to welcome everybody back to Race Prep. Done a couple picture posts. I guess it's video time because video is just a lot. Everybody uses video nowadays. For Race Prep, our subject today is a 2024 Beta 350 that we're going to do a undisclosed motor swap to. You obviously don't have to remove your motor in order to do this stuff, but since the motor's out, this is my Race Prep time. While the connectors are visible and everything's accessible, it's a good time to clean, inspect, repair any damage that you may see. Frame damage, a great time when the motor's out is see if you got any wears or rust or corrosion in certain areas that are bare metal. Some areas are going to be required to have bare metal for grounding, but some of them are going to be from damage. It's a great time to kind of scrape off the paint, throw a little primer on there and keep the corrosion to a minimum. I know a lot of us are in Arizona. Doesn't matter. Corrosion still happens because water can get trapped between your skid plate and your frame in certain areas, and pressure washing. You want to minimize the amount of corrosion, keep your frame lasting a long time. It's just a long-term race prep, I guess, is the best way. But today we're going to focus on the electrical side of the house. A lot of people really skip on the electrical side of the house. And how many times have you or your buddy been out on the trail and it's been an electrical issue? This is a great time. A lot of prep work in the beginning will save you hundreds of hours in runtime. So modern four-strokes have a lot more electrical. As you notice, this four-stroke's got a ton of electrical. It even has some bonus electrical, such as powering other accessory devices, trail techs, power commanders, so on and so forth. So while it may seem intimidating, electrical is not scary whatsoever. It's just the movement of electrons and making sure that they can move freely without getting damaged by any mechanical outside sources. I am more critical on my two-strokes. While it seems kind of counterintuitive, two-stroke has far less electrical stuff, but its failure mode is a lot greater. So if you lose an ignition coil, you're done. You're DOA, you're going back to your truck, or somebody's towing you home. So I'm way more critical on two-stroke electrical than I am on four-stroke. While four-stroke is a little more sensitive to certain things, there's more chances for it to run, just not run right, to be able to still get you home and get you back to the truck as required. So my two-strokes get a really good overbraid. They get back shells protected. They get all the full treatment on every ounce of electrical, and it's the way it should be. Four-strokes, on the other hand, bear with me. I am an electrical engineer. I'm a mechanical engineer as well, and I do not remember and name a lot of these automotive connectors. I deal with a lot of aerospace, so I deal with a lot of 38999s and connectors like that, Amphenols. So I know some of these names are like Molexes and stuff, so I'm not going to use the proper names, but you guys got the idea by kind of what we're describing today. First one I'm going to kind of pick on is I love these connectors right here. They're great. They have a nice back shell that provides a nice protection from dirt, seals them from water. While there is exposed wire, I'm not a fan of that. I'm going to still cover that up, and I'm going to take it all the way to the back shell, from the braiding to the back shell. Now this side already has a nice rubber grommet for a back shell. I'm not going to touch this. This looks absolutely fantastic to me. It's got a nice waterproof cover on each end. It snaps in. Why would I mess with that? You'll notice that Beta also has, and certain aftermarket companies have what we call snakeskin on the outers. This is an anti-chafe, anti-corrosive. It does allow dirt and water to come in. There's a big hot topic on this. If dirt gets in there, water gets in there, you may encroach upon it and it wears apart. So I like it. I have no problems with it. I just know that it does get dirty and it does allow water and dusting. One thing I don't like is connectors such as this. Even though this connector is an environmental, it's got a beautiful O-ring at the base. The back shell's got a nice sealant on the backside, which is that gray insert right there. I still don't like raw wires right here. So a lot of times, quick and easy fix. Everybody seems to be thinking that this is a very complex process to take care of your electrical work, is make sure everything's nice and dry. But a nice roll of electrical tape goes a long way. Simply by just starting at the back shell and braiding it over as best as possible will keep those wires protected, keep them kind of out of the elements, whether they're UV or water. Now, there's another hot topic right here. When I say water, this will not make it 100% waterproof. Don't think for 1 second that I'm actually waterproofing my connectors. What I'm doing is I'm just protecting them from water splashes, sprays, and say pressure washer. There is a real possibility that water gets in between these. But you'll notice that now those bare wires are now officially protected. Now I want to talk about zip ties versus wax string. I think this is the biggest thing I want everybody to kind of take away. Wax string is an extremely cheap, I think a whole roll of this stuff is like 20 bucks. And it is an extremely cheap and effective way, very lightweight if you guys come from the mountain bike community. This saves you grams of securing wires. Now I'm just going to pick on this hole for visualization. I double it up, I feed it back through, make a nice little square knot right there. One goes back through the hole from the top to bottom, the other one goes from bottom to top. And while this does take more time than a traditional zip tie, there's a couple things that I really love about these. One, it is wax. Tie a knot, bam. One, it is wax. So as this union heats up, it's actually going to make a better knot. Two is it's soft. It's a malleable material. You're not going to damage the wire. You're not going to damage the material it's mounted to. And the other thing, its softness is what also helps it in the Arizona desert. Your zip ties, if you forget about them for 10 years and you do a race prep once every 5 years, your zip ties aren't going to disintegrate or fall apart. These will stay for 10 plus years. Okay, trailside maintenance. Zip ties still need a knife. This still needs a knife. So if you're going to do a situation in which you need to get this connector off, you can untie it. A quick slice of a knife, and this thing falls apart, and keep this away. FOD. I come from aviation, so FOD's a very big thing. I don't want hard plastic stuff around my moving motor. While the chain can eat a zip tie, wax string is guaranteed never to be an issue. I know we don't use zip ties around our intakes and exhausts. I wouldn't recommend wax string or zip ties around your exhaust, but FOD's not an issue. So you don't have to worry about it breaking, keeps them nice and secure, and you can do a nice daisy chain all the way down your harness, securing it in a very lightweight fashion. And if you find that you need to change some things or alter some things, it's real easy. Cut it off, move on with life. It's super cheap and easy. It can go in your trail pack. You can only fit so many zip ties in your trail pack. This entire roll, you can fit 100 yards of this stuff in your pack and be able to tie up most things. Now there are two different variations. There's the black generic use, general use, and then there's white. This is more of a fiber based. The white is fiberglass based and used for high temp environments in which you need to secure things kind of away from your engine, or you need to keep harnesses away from the heat, but you're worried about melting this. It's a great use for that. Both options are readily available on the internet. Just go find a spool, keep it really close, and it'll clean up your wiring a lot. So I guess the biggest takeaway is even these connectors right here, while you have them out, race prep is a lot about preventing future problems or problems that can happen under high stress environments such as a AA race environment. If this is out and it's dirty, as you can see, it takes 2 seconds with a Scotch-Brite pad to clean that up and give you a good ground source. Same with your starter. You see the little bit of black ring right there? That's going to come off. That's mating surface right there has a little bit of dirt on there. I'm going to take a nice Scotch-Brite, alcohol. I don't want my starter failing, nor do I want any possibility of a future failure. Dielectric grease is good in moderation. Stop using a gallon of it on each connector. This is a perfect amount. That little bit of swipe, you made my thumb a little bit shiny, keeps the water, it repels the water out a little bit in the event that anything gets in there. Now in Arizona, this is a hot topic as well. Dielectric grease, if it's not inside of the connector, will cake up and actually build up dirt on the outside of the connector, leaving the connector subject to a dirt buildup. Now imagine pressure washing and pushing that dirt into the connector. So be very careful and use dielectric grease in very much moderation. Molex connectors like this, I try not to use these in the event I see these. The reason I don't use them is, you notice on the back shell, there's absolutely no protection. You can see the connector all the way through. There's no O-ring or sealant in between the two junctions, and you can see it on the other side as well. This is the epitome of, I'm gonna clean this very well, and I'm gonna use electrical tape to cover this at all costs, all the way top to bottom, getting the overbraid, and making sure that not only will this have a good connection, it's also going to be as minimal amount of dust and dirt as you can humanly get. This is race prep at its core for the electrical side of the house, is making sure that what could have been a dirty connector causing me a loss of power to the power commander is now environmentally protected, while not environmental proof. It's at least environmentally protected, anti-chafe protected, and it's nice and secure. Now this entire wire, I'm gonna put heat shrink or snake skin over this and the rest of this and protect it the same way that your factory wires have the snake skin protection or some sort of heat shrink protection over them. Movement is bad. You don't want movement in a harness. Secure is where you want to be. I'm actually going to wax string this entire harness to this, so as you go flying through the whoops, nothing moves. Now Beta's got a scorpion design, as most bikes do, and this is the pivot point. I'm going to also ensure that I secure it here and secure it here, which allows a flex when I move the tail up, that the harness can move with the entire assembly, and I'm not bypassing a really cool feature of the bike. Get into your harnesses. You don't have to take your motors out. You do have to disconnect them. Contact cleaner, carb cleaner. You want cleaners that don't leave a trace of residue behind, hence carb cleaner and brake cleaner. Clean out your connectors, get them nice and clean, get them nice and working good, keep the O-rings nice and clean, put it all back together, secure it with electrical tape to keep the dirt and crap out, and even your pressure washer out, and you'll have a long electrical life with as minimal amount of errors as humanly possible. So good luck. I hope this helps. I'm going to kind of show a picture after this video of what this harness looked like. You guys can see it in the video now, and I'll show a picture of after. While it may not look like much, I'm probably going to spend about 10 to 20 hours of just redoing harnesses. Oh, actually, the funny thing is right here, there's a wax string from a previous race prep that I've done. That's got approximately about 60 hours on it. Bundles the harnesses nice and well. So let me know if you have any questions. We're going to keep going with this. This series is going to continue. Once we get done with the electrical side of the house, we're going to talk mechanical side of the house. And we're going to talk torque stripe and torques and environmental protection and keeping your bike as race ready as humanly possible. And what is good and what is bad. I love this topic with dirt bikes. What is truly good to run versus what is really bad. So that'll be a whole nother video. Hope you guys enjoy, and let me know if you have any questions.